Now we'll see the measurement of pressure using the apparatus called as U-tube manometer, and this is the apparatus which is in the shape of U-tube. And here let me take a point in this pipeline which has some pressure, and I have to measure this pressure. Let me assume this pressure as PA. So I have to find this pressure using this apparatus. And inside the apparatus, you see I have some fluid which I have shown in different color to distinguish. So here till this I have some fluid which is called the working fluid, which has density, consider ρ1. And from here to here we have another fluid which is called as manometric fluid, and this has density ρ2. Now here the interface between both the fluids, here let me take this point as B, this region as B, and this region as C. And the pressure, let me take the pressure. The pressure here is PB, and here the pressure is PC. Now B and C both are at the same height from the bottom of the manometer, and the height here is, let's take it as H0. Then we'll measure the height of the fluids. So you see from here to here we have the working fluid, so the height here is, let's take it as H1. And for the manometric fluid, we have to measure it from the top to the bottom of the U-tube manometer, and let me take this as H2. Now the B and C are at the same height, so the pressure also will be equal, so I can write PB will be equal to PC. Now separately I'll find out PV and PC, and then I'll be equating it. PB, pressure at B, will be equal to this. The pressure at B is as a result of the pressure PA. This will be imposing some pressure on this region, and also the working fluid also will be imposing some pressure. Even the working fluid will be imposing some pressure. So I have to consider both. So PA is imposing some pressure on B, plus the working fluid is imposing some pressure. So the pressure due to some fluid can be found using this relation. P is equal to rho GH, and here this is the working fluid, so the density for this is ρ1 into G into the height of this working fluid is H1. So this is how we can measure the pressure at B. Similarly, the pressure at C can be found using, you see here I have some manometric fluid here. So this manometric fluid will be imposing some pressure on C. So that is the manometric fluid, the density for that is ρ2 G into the height here. You see the height that we get here, that is H2 minus H0. I'll be getting the height. So let me write this H2 minus H0. So this is the pressure due to the manometric fluid. And also you see this end is open to the atmosphere. This is open to the atmosphere. So also the atmospheric pressure will be imposed on C. So P atmosphere. So this is the pressure we get at C. Now I can write, since PB is equal to PC, I can write PA plus ρ1 G H1, that will be equal to P atmosphere plus ρ2 G H2 minus H0. Then this can be neglected because this is the working fluid pressure, and the density ρ1, the density of the working fluid is very less than the density of the manometric fluid. So I can neglect this. So I'll just have PA, that is equal to P atmosphere plus ρ2 G H2 minus H0. Then I can write PA minus P atmosphere, that is equal to ρ2 G H2 minus H0. Now let me say you this, that PA minus P atmosphere, this is called as the gauge pressure. This is the gauge pressure. So what I can get from here is I can get the gauge pressure, and the value of the gauge pressure will be ρ2 G H2 minus H0. So this is actually the pressure we got due to the manometric fluid, isn't it? So this is because of the manometric fluid pressure, which is also called as the gauge pressure. So the equation, that is this equation, we can find out P atmosphere, and P atmosphere we can find using the barometer. The atmospheric pressure is measured using the barometer, and this is we can find out using the U-tube manometer because it's the manometric pressure. So both can be found, atmospheric as well as the gauge pressure. This is the gauge pressure, both can be found. And when we find both, we can find out PA. Actually, we have to find this PA. So I can write PA will be P atmosphere plus gauge pressure. So we can find out the pressure at A inside this.